F-35 program is one of the most ambitious, expensive, and controversial military projects in modern history. Conceived at the end of the Cold War but shaped by the conflicts of the 21st century, the F-35 Lightning II was designed to be more than just a fighter jet. It was meant to be the backbone of Allied air power for decades, a single family of aircraft capable of replacing multiple aging platforms while dominating the skies through stealth, sensors, and data fusion. To understand why the F-35 inspires both admiration and criticism, we need to explore its power, its problems, and what the future truly holds for this revolutionary aircraft. At its core, the F-35 is built around stealth. Unlike older fighter jets that rely mainly on speed and maneuverability, the F-35 is designed to avoid detection in the first place. Its shape, internal weapons bays, radar-absorbing materials, and heat management all work together to reduce its radar and infrared signature. This allows it to penetrate heavily defended airspace where traditional aircraft would be detected and targeted long before reaching their objective. In modern warfare, where advanced air defense systems can track and engage targets at extreme ranges, stealth is not a luxury, it is a necessity. But stealth alone does not define the F-35's power. The real strength of the aircraft lies in its sensors and its ability to fuse information. The F-35 is often described as a flying computer, and this description is not an exaggeration. It carries an advanced radar, distributed aperture system, electro-optical targeting system, and electronic warfare suite, all feeding data into a single, integrated picture for the pilot. Instead of juggling multiple screens and raw sensor inputs, the pilot sees a clear, prioritized view of the battlespace. Enemy aircraft, surface threats, friendly forces, and targets are all displayed in a way that improves situational awareness and reduces pilot workload. This data fusion transforms the F-35 from a standalone fighter into a battlefield commander in the air. It can share information with other aircraft, ships, ground forces, and command centers in real time. Even older, non-stealth aircraft can benefit by receiving targeting data from an F-35 operating deep inside hostile territory. In this way, the F-35 does not just fight battles, it enables the entire force to fight more effectively. Another key aspect of the F-35 program is its multi-role design. The aircraft was developed in three main variants, one for conventional takeoff and landing, one for short takeoff and vertical landing, and one for aircraft carrier operations. This common design approach was intended to reduce costs, simplify logistics, and allow allied nations to operate a shared platform. The F-35 can perform air-to-air combat, close air support, intelligence gathering, and precision strike missions, often in the same sortie. This flexibility is especially valuable for modern militaries facing diverse threats across different regions. Despite these impressive capabilities, the F-35 program has faced serious problems since its inception. Cost is the most famous and most criticized issue. The program became the most expensive weapons system ever developed, with total lifetime costs reaching into the trillions of dollars when development, production, maintenance, and upgrades are included. Early cost overruns and delays damaged public and political trust, turning the F-35 into a symbol of defense spending excess in the eyes of many critics. Technical challenges also plagued the aircraft, especially in its early years. Software development proved far more complex than expected. The F-35 relies heavily on millions of lines of code, and delays in software maturity limited the aircraft's capabilities during initial deployments. Early pilots reported issues with reliability, maintenance times, and availability rates. Problems with spare parts, logistics systems, and maintenance planning made it difficult for operators to keep enough aircraft mission-ready. Performance criticisms added fuel to the controversy. Some critics argued that the F-35 was not as agile in close-range dogfights as older fighters, while others questioned its effectiveness in traditional close air support roles. There were also concerns about the aircraft's engine, helmet-mounted display, and vulnerability to cyber threats. Each reported flaw was amplified by media coverage, reinforcing the perception of a program struggling under its own ambition. However, it is important to understand that many of these problems occurred during development and early operational testing, a phase where complex systems are expected to face challenges. Over time, many issues have been addressed through upgrades, improved maintenance practices, and refined training. Production costs per aircraft have steadily decreased, making newer F-35s significantly cheaper than earlier models. Availability rates have improved, and pilots now report greater confidence in the aircraft's systems and performance. The debate around the F-35 often ignores a key reality of modern warfare: air combat is no longer defined primarily by dogfights. The F-35 is designed to detect, track, and engage enemies long before visual contact. Its strength is in information dominance rather than pure maneuverability. In exercises and real-world operations, the aircraft has demonstrated its ability to see first, shoot first, and kill first, often without being detected at all. Looking to the future, the F-35 program is far from finished. In many ways, it is just entering its most important phase. Continuous upgrades are planned to enhance its sensors, weapons, electronic warfare capabilities, and computing power. New software blocks will allow the aircraft to carry more advanced missiles, improve data sharing, and adapt to emerging threats. The F-35 is designed as a platform that evolves over time, rather than a static aircraft frozen at the moment of its first flight. International adoption is another major factor shaping the future of the program. Numerous allied nations have chosen the F-35 as their primary fighter, creating an unprecedented level of interoperability. Pilots from different countries can train together, share tactics, and operate seamlessly in coalition missions. This shared platform strengthens alliances and creates a common operational language in the air. At the same time, new challenges are emerging. Potential adversaries are developing advanced radar systems, electronic warfare tools, and counter-stealth technologies. Cybersecurity will remain a critical concern as the aircraft becomes more networked and software-dependent. The success of the F-35 will depend on how well it adapts to these evolving threats and how effectively its users continue to invest in training, maintenance, and upgrades. In the end, the F-35 program represents both the promise and the risk of modern military innovation. It is a powerful symbol of how warfare has shifted toward information, integration, and technology. Its problems serve as a reminder of the complexity and cost of pushing the boundaries of what is possible. And its future will be shaped not just by engineering, but by strategy, cooperation, and the realities of global security. Whether viewed as a masterpiece of modern aviation or a cautionary tale of overambition, the F-35 is undeniably changing the way air power is understood and employed. It is not just a fighter jet, it is a system, a network, and a long-term vision of how wars may be fought in the decades to come.